In question number 39, we have integral from 0 to 1 sine inverse x dx. Yes. And what will we do? We can make a substitution by integrating, or we can directly apply by parts. Both the choices are available. So sine inverse x can be taken as a first function into 1. 1 can be taken as a second function, then we can think of integration. Yes. Or we can make a substitution first and then think of integration, right? So sine inverse x can be substituted as t. LHS has I equals integral of 0 to 1 sine inverse x dx. Put sine inverse x is equal to t. What does that give me? That gives me x equals sine t, or that tells me dx is equal to cos t dt. Therefore, I will be equal to lower limit. T is sine inverse 0. Upper limit is sine inverse 1, which is pi by 2. This is what you get. Sine inverse x is t, dx is cos t dt. And at this stage, I can apply by parts. This trigonometric will be my second function. This will be my first function. Algebraic trigonometric. Algebraic will be first and this will be second. This integral will be first function times integral of second function, which is sine t, minus derivative of first integral of second, which is sine t dt, putting the limits 0 to pi by 2. This is what you have, right? Let's integrate that other term. This t sine t remains as it is, minus this integral of sine t will be minus of cos t, so this becomes plus cos t from 0 to pi by 2. Yes, here I would like to discuss one more thing. What's that you want to like to discuss? I want to discuss integral of sine inverse x dx, indefinite integral. Now if you observe, up till now we have interchanged the limits, but at this stage, if we replace t in terms of x, you will get the integral of sine inverse x. Yes or no? Integral of sine inverse x before you put the limits, right? Integral of sine inverse x, what is that? T is sine inverse x, sine t is x, so this is x sine inverse x plus cos t. Cos t is under root of 1 minus x square plus a constant. This is the integral of sine inverse x. This is something extra which you can remember maybe. Yes. X sine inverse x plus under root of this. Okay. If ever you have a confusion, simply differentiate this, whether plus or minus. Okay. So at max you will have a confusion between this plus or minus. I am assuming that. Otherwise, you can think that integration of this will be using by parts. So 1 times sine inverse x, that will be x times sine inverse x plus something. Something is under root of 1 minus x square, which is nothing but the denominator of derivative of this. Right? This is what you get. What else? Simply put the limits over here. This is pi by 2. Sine pi by 2 is 1 plus cos pi by 2 is 0 minus this is 0. Cos 0 is 1. This becomes pi by 2 minus 1. That is my required answer, or which we wanted to prove, hence proved. Is there any other way to deal with this? Yes, there's another way, which is using applications of integrals, that is using area concepts. Sine inverse x, this is the curve of sine inverse x from 0 to 1, and we want this particular area over here. So for directly solving this, I want you to remember one thing. What is that? Remember this. This is x-axis, this is y-axis, and this is the graph of y is equal to sine x. So in this graph, I want you to remember one thing. What is that? This will be quite useful at a lot of places. What is this area? From 0 to pi by 2 of sine x. This particular shaded region will have area equal to 1. This particular shaded region will have area equal to 1. Each of these shaded region in the graph of sine x will have area equal to 1. Right? This is area equal to 1. And if you observe, this is nothing but the mirror image of this, and we want this one over here, right? As per this calculation, we want that other area, which is nothing but the area of this rectangle minus this shaded region, right? Area of rectangle is length into height. This is pi by 2 into 1 pi by 2 minus this area, this is pi by 2 minus 1. That's another way of dealing with this whole thing. Here, obviously, we'll have to use this one. Along with that, we need to remember this. And another idea is using applications of definite integrals. This is what you can see. Right? This is question number 39 for us.